Good morning, everyone. My name is Chi, and together with my partner Itong, we will be presenting our mathematics learning activity for today. In this presentation, we will demonstrate how selected learning theories can be effectively applied in the design of a primary school mathematics activity. Our focus is not only on explaining the theories, but more importantly on showing how these theories can be translated into meaningful classroom practice. We will be presenting an activity titled Stick Triangle Investigation. It is designed for Year 5 people under the mathematics subjects, specifically in the learning area of geometry. The activities aligns with the DSKP curriculum standard which requires pupils to recognize and name right angles, acute angles, and obtuse angles in rectangles, squares, and triangles.
So, the learning objective of we make this activity is at the end of the class, students will be able to classify triangles by size and recognize the right angle, acute angle, and obtuse angle. And the last one is investigate the triangle properties. Okay, now let's watch our activity video.
Good day, everyone. Okay, today we are going to play mathematics games. So everyone can see the stick on my hand. Is that they have any difference? Yes, good. So is this stick can become to form a triangle?
Teacher, I think cannot. No, cannot.
Why?
Because I think they have different lengths, so it cannot become a triangle. No. I think it has many different of thickness.
So next.
Okay, so today we want to do an activity. Okay, give me the one. I will give us 4 packs of this, and inside the 3 sticks, and you need to make the triangles, make an triangles, and after that you need to write down the triangle names. Okay, go.
But we got no pen.
Okay.
Wow, 3 different sticks. What is this? Teacher, what they are so different?
You cannot eat it. You need to use this different stick and build the triangle. So
difficult.
okay, I will give you. What is this? Glue. Yes, glue. So after you build the triangle, yes, you see this is a good example.
Wow.
Is this is the triangle?
Yes, absolutely yes.
Why?
Because it has 3 sides.
And
Different angle.
different angles.
And
Okay, so
built by 3 sticks.
okay, never mind. After you build this, right, and you need to paste on the paper. Okay? You need to share use this glue.
Okay, share.
And after that you need to write down.
Okay. Wow, right angle triangle.
Wow, so smart.
Wow, right angle. Okay, next. Oh, what is this? Somebody three, 6.
This one is the equilibrium triangle.
Three same side.
Yes! Very good! Nice! So, the second is isosceles triangle. The isosceles triangle is have two same sides and one different. So, can anyone tell me that which one is the isosceles? Is scaling triangle. So the scaling triangle is three different length sides. So can you guys tell me which one is that?
What can you observe if with the other triangle have any difference?
Last triangle has one.
Yeah, and you?
It seems like 90 degrees.
Yes, the right angle is 90 degrees. Is other triangle have 90 degrees? No. So and the last one is what? What triangle? You guys?
Right angle triangle.
Yes, the last one is right angle triangle. Okay, so before I give you this paper, can you answer teacher what is the acute angle?
Acute angle. Acute angle. What angles that smaller than 90 degrees?
And bigger than 90 degrees but smaller than 180 degrees. Ooh. Okay, good try, Queenie, but not the accurate answer. Acute angle is the angle is less than 90 degrees. So you think cube, right? What is your think? What you think after the word cube? It's small, cube, right? The cube is cube, right? So you think acute angle is cube one, the small one. So it's less than 90 degrees. Okay. And the other is obtuse angle. What is obtuse angle?
I know already.
What?
Obtuse angle must be more than 90 degrees, but less than 180.
Whoa! Okay, give a big clap to me. So smart. Okay, so I give you this paper, and you need to fill out what you observe after the triangle you build.
so now I give you to try and to measure the angle that you have made.
Okay, oh, so this one is. How to measure? I don't know. Never mind, teacher will help. Is 45 degrees.
So this is right angle triangle.
Wow, smart lens.
And no leg.
This is a cube, right? This is a cube. No, a cube. 0.5. This is a cube. This is obtuse.
One.
So, guys, what you learn today?
Different length of sticks can build different type of triangle.
Yes.
I learned acute angle and obtuse angle.
Oh, very nice. You think that these classes is interesting or not? Very good. So, it's the ending. Bye.
Thank you, teacher.
In this activity, pupils work in individual to actively explore the properties of triangles using the sticks. First, they construct different triangles by manipulating the sticks provided. Through this process, the test with combination of sides length are able to form the different triangles. Next, pupils classify the triangles according to their different sides, such as equilateral triangle, isosceles triangle, right angle triangle, and scalar triangles. After that, they further investigate the types of angle formed within the triangles, identify whether they are right angle, acute angle, or obtuse angle. Overall, this is a hands-on exploratory activity that encourages pupils to learn through active manipulation, investigation, and discussion rather than passive listening. For this activity, we selected two learning theories that best support the design and implementation of our lesson. The first theory is Bruner's learning theory, and the second is the contradism learning theory.
According to Bruno, learning should not be a passive process where students simply receive information from the teacher. Instead, learners should actively construct their own knowledge through exploring, observing, manipulating, and thinking. In our stick triangle investigation, pupils are encouraged to try things out on their own. They physically manipulate the chopsticks to form different triangles, testing which combination of sides successfully close into a triangle. So at the same time, they look for patterns such as which triangles contain a right triangle or how the side lengths influence the angles. By doing so, pupils actively build their understanding of geometry relationships, which aligns perfectly with Bruno's principle of discovering learning.
Next, structure. Bruno emphasized that teaching content should be organized in a clear and meaningful structure. This allowed students to see the relationship between different concepts rather than learning them in the classroom. In our activity, This principle is applied as pupils do not merely memorize the different types of triangle, such as equilateral triangle and isosceles triangle. They actively explore how the length of sides affect the angles formed and how angle relate with the another within the angle. By exploring this relationship directly, pupils build a deeper and more connected understanding of geometric concepts, which aligns with Bruner's idea that structure, content, and has meaningful learning. Now, let's look at Bruner's idea of representation, which is about how learners understand and express knowledge. He suggested that there are three main ways to represent information. The first is an active representation, which means learning through action and hands-on experience. In our activity, students construct triangles using sticks. By physically building the triangles, they can directly observe the shapes and relationships between sides and angles. This is a way of learning by doing. The second is iconic representation, which means learning through image, diagrams, or visual models. Students can draw the triangle they made or look at diagrams showing different types of angles. This helps them to see the patterns and understand the concept visually. The third one and also the last one is the symbolic representation, which use language, symbol, or mathematical notation. For example, students can label angles with symbols like 90 degree and write the name of triangle types such as equilateral, isosceles, and scalene triangle. And the language is the way that the sentence that we communicate.
Next, we will move to the constructivist learning theory, which is the content with active constructions, schema theory, social interactions, and also reflective thinking.
Now, let's talk about active construction. Learners are not empty vessels waiting to be filled with knowledge. Instead, they build their own understanding through hands-on experience, exploration, questioning, and problem solving. In a classroom setting, students learn best when they are actively involved in activities rather than just listening the teacher explanation. In this activity, students are not just sitting and listening to me explain the different types of triangles. Instead, they got to do it themselves. First, they construct the triangle using the sticks. Then, they test whether the three sides can actually form a triangle. Then, finally, they identify and classify their triangle as the types of the triangles. Through this hands-on exploration, students actively build their own understanding. They learn not just the name of the triangles, but also the properties of each triangle, the relationship between sides and the angles, and the difference among the types. This makes the learning such more meaningful because students discover the concepts themselves rather than just memorizing the definition from the textbook.
Next, I want to explain how schema theory works in our stick triangle investigation activity. Before students start the activity, they already have some basic knowledge about triangles. For example, they know that a triangle has three sides. They also know that triangle has three angles and also that a right angle is 90 degrees. These are their existing schemas, the mental structures they already have about triangles. So when students begin building different triangles with stick, they encounter new experience. For example, when a triangle has three equal sides, and they can see that it also has three equal angles, so this is an equilateral triangle. When a triangle has two equal sides, then notice it has two equal angles. So this is an isosceles triangle will be their mind. And some triangles do not have a right angle but are still valid triangles. Through this hands-on experience, students are modifying and expanding their existing schemas. They are not just memorizing names, and they are understanding how sides and angles are related and how different types of triangles are structured. This is show the main idea of constructivism and schema theory. Learners actively connect new experience to prior knowledge and gradually build a deeper understanding. Now, let's look at social interaction and how it helps in our stick triangle investigation activity. In this activity, students work in individual to build different types of triangles using sticks. While doing this, they share their ideas about which triangle they are making with others. They also discuss and challenge each other's perspective, for example, whether an angle is acute, right, or obtuse. Clarify misunderstandings if someone measures an angle incorrectly or labels a triangle the wrong way. By talking and collaborating with their peers, students develop a deeper understanding of triangles and the relationships between sides and angles. This shows how learning is socially constructed. Students learn not just by doing, but also by interacting, explaining, and discussing with others.
Finally, let's talk about the reflective thinking in my stick triangle investigation activity. After constructing and measuring their triangles, students are given a reflection table to evaluate their understanding of the properties of each triangle. This helps students ask themselves, do I really understand the property of this triangle? If they feel unsure, they can remeasure the angles or discuss again with their friends. Through this reflection process, students identify the misconceptions, clarify properties, and strengthen their understanding of the relation between sides and angle. This shows the learning is not just about doing the activity, but also about thinking about what they have learned. In conclusion, this stick triangle investigation activity demonstrates how learning theories can be meaningfully applied in real classroom practice. Bruner's learning theory supports the student's progressive conceptual development from concrete manipulation to abstract understanding. Constructivism emphasizes the active exploration, discussion, and reflection, allowing the student to construct the knowledge based on the experience rather than memorization. The integration of these theories can enhance the concept clarity, strengthen the higher order thinking, and ensure the meaningful understanding of mathematical concepts. Therefore, the integration of learning is practiced that significantly enhance pupils' understanding of mathematical concepts and ensure that learning is meaningful rather than mechanical.